Welcome to this explainer. Today, we're taking the technical manual for the Redstone DGW100 SIP-ISDN gateway and transforming it into a straightforward, no-nonsense deployment guide. Listen, if you've just unboxed this piece of hardware and you're thinking, okay, how do I actually perform the initial setup and get the basic network configuration dialed in? Well, you are in exactly the right place. We're going to get your system online and, more importantly, we're going to get it secured. So let's dive right in. Here is our game plan for today. First, we'll meet the DGW100. Then, we'll run through the local debugging setup, tackle the basic network configuration, hit the SIP and ISDN setup, and wrap things up with some absolute security essentials. All right, Section 1. Let's meet the DGW100. Before we actually start plugging cables into this thing, let's take a second to understand the sheer capacity of the hardware you're dealing with. This little compact device really packs a punch. It's engineered to seamlessly handle up to 120 simultaneous VoIP calls at any given time. And on top of that crazy call volume, it supports a massive 1,000 SIP trunk account registrations. It is just a highly capable, rock-solid bridge for your enterprise communications. Taking a quick look at the physical layout here, you'll notice it's built entirely for enterprise reliability. It features up to 4 T1 or E1 spans, gigabit Ethernet ports for that high-speed data transfer we all want. And this is absolutely crucial for your uptime. It supports dual network and power supply redundancy. Basically, if one power source fails, your communications are going to stay up and running without missing a single beat. Moving right along to Section 2, Local Debugging Connection Setup. Okay, so this is arguably the most critical part of the whole process, your very first logical connection to the gateway right out of the box. To get in, you'll simply connect your debugging computer directly to the device's WAN port using a standard Ethernet cable. Next, you got to do the classic subnet dance. Align your computer's IP address to the gateway's default subnet. So go ahead and set your PC's IP to 192.168.2.100. Once you've got that applied, open up your web browser and navigate directly to the default admin address, which is https://192.168.2.240. And if you've matched up your subnets correctly and navigated to that address, boom, you will be greeted by the administrator login interface. Seeing this screen is the ultimate green light. It signals that you're in and totally ready to configure the system. All right, Section 3, Basic Network Configuration. Now that we actually have administrative access, our first major task is establishing the gateway's permanent identity on your local network. We need to get it off those default settings ASAP. So head under the Network tab. Here is exactly where you're going to assign your static IP address, define your custom subnet mask, and input your default gateway and DNS servers. Look, setting a static IP is absolutely critical here, so your other SIP devices always know exactly where to route traffic. Double-check your numbers on this page, and then confidently hit save. Which brings us to Section 4, SIP and ISDN setup. So with the basic network plumbing completely finished, let's take a look at the SIP settings. You're going to need to accurately input your registrar server, your proxy server, and the subdomain name. Now, these specific details, they are provided to you directly by your SIP trunk provider or maybe your internal network admin. Entering these flawlessly is basically non-negotiable if you want to ensure successful SIP registration. Then flipping over to the legacy telecom side, on the ISDN configuration tab, we need to define the physical characteristics of your telecom circuits. This right here is where the digital meets the physical, and you have to tell the gateway exactly what kind of line it's talking to. You really need to pay close attention to your region here, as the standards completely change depending on where you are in the world. For instance, North American setups require you to select the T1, DS1 type, and the ULA PCM codec. Conversely, most other international regions are going to utilize the E1 setting and the ALA codec. Getting this backward? Yeah, that's a guaranteed way to keep your lines totally disconnected. It's literally like trying to force two devices to speak two completely different languages. So, the most crucial point on this setup page is regarding the timing source dropdown. Timing synchronization is what keeps all those audio packets aligned perfectly. Setting this to local forces the DGW100 itself to synchronize the connection. Someone has to set the tempo, right? And this is vital if the network side isn't providing the clock. One side always has to provide it, so make sure you coordinate this with your telecom provider. And finally, Section 5, Security and Maintenance Essentials. Okay, your gateway might be routing calls now, but as any IT pro knows, functional is definitely not the same as ready for production. Let's talk about some mandatory pro tips for locking down your perimeter. First off, immediately change the default HTTP and HTTPS web server ports to hide from automated network scanners. Next, you absolutely must activate the voice security function. This ensures the device only accepts SIP signaling from trusted IP addresses. Honestly, that is your primary defense to prevent the absolute nightmare of illegal outbound toll fraud. And finally, get those IP whitelists configured for management access. Actually, speaking of that whitelist, it is incredibly strict by design. As a hard limit for administration security, you can add a maximum of exactly 20 IP addresses to the whitelist. This ensures only specific, highly trusted management machines can even attempt to access the web interface, telnet, or SSH services. It's a surprisingly small configuration step that massively shrinks your attack surface. All right, finally, a quick tip for when it comes to troubleshooting. If your physical lines just aren't cooperating, check the link status. Seeing an IS state means in service, which indicates successful link layer negotiation. However, if you see an OOS or out of service state, that usually points to a physical or configuration mismatch. Most of the time, it's reverse settings between the user and network sides, or just a simple 12-ohm cable sequence error. So before you walk away from the server rack, dust off your hands, and declare the job done, ask yourself this one final question. Are all my default ports changed? And is this gateway truly secure and ready for live traffic? Make sure you haven't just, plugged in a device, but that you've properly secured a vital piece of your unified communications infrastructure. Well, I really hope this explainer gave you exactly what you needed to pull off a seamless deployment today. Thanks so much for learning with me.